everyone, I hope everything with Upward Bound is going well. Today we're going to look at the periodic table and why it's shaped the way it is, and also compare that to valence electrons because the periodic table's shape is actually based on valence electrons. So the two ways to describe a periodic table is groups, which are up and down, and a group number would be 1, 2, 3, 4, 5, 6, 7, and 8. Oh, that got cut off. So group number is the column. It is this entire area there. Now, the other way is a period. A period is the row, left and right. So the periods would be numbered like this. This would be period 1, this would be period 2, 3, 4, 5, and so on. Because they go left to right. Now, that makes sense actually with valence electrons, because we learned that valence electrons in the first shell can only go to 2. That makes sense because the only two elements in period 1 are hydrogen and helium. So there wouldn't be a way to go above 2. This also makes sense with why in shells 2, 3, and so on, there's 8 valence electrons. That makes sense because let's count the elements. 1, 2, 3, 4, 5, 6, 7, and 8. That's why in period 2 we see 8 valence electrons. That is how the periodic table gets its shape, with those 2 at the top and then the rest of the rows being 8. Now you might see this box here doesn't really fit with what we're learning about. These are called transition metals. And they're in a little more advanced chemistry because they don't follow the same patterns that I'm talking about right now. So we're going to ignore them for now. You'll learn them later, either later in this class or later in your chemistry careers. So, let me keep that X'd off so we don't cause any confusion. How can this help us determine valence electrons? Well, it actually makes it really easy. Because if you picked an element on the periodic table, let's pick carbon, for example, since it's in group 4 right here, that gives us the answer on how many valence electrons it has. If carbon is in group 4, then that means it has 4 valence electrons. This works with every single group. Group 1, I'll have 1 valence electron. Group 2, I'll have 2. Group 3, I'll have 3 valence electrons, and so on. You have to be a little careful with 8 here, because helium, remember, only has 2, but the rest of these all have 8. Alright, let's make sure that this works by doing a couple examples. Picking carbon, for example, let's draw the structure of carbon and see if it matches. Now we know carbon has 6 electrons because its atomic number is 6 and we know it's neutral. So if I was going to draw carbon, I would want to draw 6 electrons. Now, the periods can be really helpful in drawing structures because the periods tell us the number of shells. For example, period 1, I'll have 1 shell. Period 2, I'll have 2 shells. Period 3, I'll have 3 shells. Since carbon is in period 2, it has 2 shells. So if I wanted to draw carbon, I would draw 1, 2 shells around it. Now I know that that first shell has 2 electrons, and we know that it has to have a total of 6. Oops, I drew those wrong. 2 electrons. And I know it has to have a total of 6. So if we did 6 minus 2, it would equal 4. So using the group system worked. 4 was the correct number. It had 4 valence electrons. Let's try a slightly bigger element to see if it works. Let's try sulfur over here. Now sulfur is in period 3. That means that it has 3 shells around it. Let me draw those. 1, 2, and 3. Now, if we were using the group system, we would say since it's in group 6, it should have 6 valence electrons. Let's see if that's right. In shell 1, we know we have 2, like always. In shell 2, we know we have 8, since it is a full shell. And in shell 3, we have to get to atomic number 16. All right, well, 16 minus 8 minus 2 does equal 6. So it works. So the valence electrons of sulfur is 1, 2, 3, 4, 5, 6. And that will be what sulfur looks like. So you can do this in multiple ways. You can either draw the structure each time and make sure that you get to the atomic number every time, or you could just use your periodic table, find what period it is in, find what group it is in, and that should get you the answer. So there's a lot of ways to find valence electrons, but it is really cool how it works with the periodic table and the periodic table shapes. Perfect. Thanks, guys. Hope this unit is going well for you, and hope you are all staying safe and healthy.